Your homework over the next couple days are going to have you guys solving problems about objects that are moving that are changing their velocity. So the title of it's called Quantitative Acceleration Problems. And you're going to be working through this homework assignment, eventually solving all 10 of these problems 2 different ways. At this point, we know how to solve accelerated motion problems or problems about objects that change their velocity using graphs, either position versus time graphs or velocity versus time graphs. And so you're going to actually solve the first 9 problems. You're going to solve them graphically using a quantitative velocity versus time graph. At this point, I only want you guys to do those graphical solutions for number 1 through 7 out of those 10 problems. Eventually, we'll come back and do number 8 and number 9 graphically, and then we're going to actually learn another way of solving these same problems. Instead of using quantitative graphs, we're going to use algebraic representations or just algebraic equations to solve the same exact problems. So even though there's red X's on here to remind you at this point, don't do the algebraic solutions, don't X it out because you guys will be coming back and doing those things eventually. So let me walk you through number 1 real quick, not all the way, but the setup, just so you guys know what you're doing for each of the problems for the graphical solutions. So number 1 says, a Toyota Prius can accelerate from rest to a speed of 60 miles an hour or approximately 28 meters each second in a time of 10 seconds. A, what is the average acceleration of the car over that 10-second time interval? And B, what is the car's displacement during this time? Again, those 10 seconds. So when you guys come to the problem, read the question prompt, and then I want you guys to first draw a picture and a motion map of the scenario that's described, in this case for a Prius. So what would that look like? Well, let me give you guys an example. So I've got a motion map of an object that I've drawn moving in the positive direction and increasing in speed, so it's got a positive acceleration. So sketch out a little motion map, draw a little picture. I've got a simple picture of a car. At time 0, it said it started from rest, so its initial velocity, v sub 0, is 0 meters per second. I want you guys to basically write down on the picture information from the question prompt. It said it reached a final speed of 28 meters per second, so after some time, its final velocity, or just v sub x, would be 28 meters per second. And then to get from the initial time to the final time, or the initial velocity to the final velocity, there was a change in time of 10 seconds, and so you could maybe label it like that. And then one of the things that you're going to ask to find is average acceleration, so we could write A equals question mark. We're trying to find the acceleration, and we're trying to find the displacement, so we could write change in x, or delta x equals question mark. So that's kind of in general what I want you guys to do. Draw a picture, label things and values from the question prompt on your picture, and sketch out a quick little motion map. The next part is the graphical solution. So you're going to be answering these 2 questions, A and B, using a quantitative velocity versus time graph. So, like I said, for the graphical solution, first, you're going to create a velocity versus time graph based on the information given in the problem. So, well, let's do that right now together. At time 0, it started from rest. So at 0 seconds, it's got a velocity of 0 meters per second. And after 10 seconds, it has a final velocity of 28 meters per second. So at 10 seconds, we're going to put another dot right about there saying it's 28 meters per second. It doesn't say this, but we are going to make the assumption that there's a uniform or constant acceleration for all of these scenarios in this worksheet. A constant acceleration or a uniform acceleration, remember, means that the velocity changes linear. There's a linear change in velocity over time. And so from our initial velocity to our final velocity, we're just going to draw a straight line connecting the two, showing a constant acceleration. Once you've made your quantitative velocity versus time graph, now you're going to use that graph to answer the questions in the question prompt, which was part A was find the average acceleration. So what's the acceleration? And again, you're going to use this graph to find the acceleration. And then B wants you to find the displacement. Again, you're going to use this quantitative velocity versus time graph that you just drew to solve for the displacement. And you're going to put that work down here right where it says work for the graphical solution. The box underneath all of that, if you're looking at your worksheet, that's the area I want you guys to leave blank, where you guys are going to eventually be doing the algebraic solution, which is this stuff right here.